All right, Sprang Gang. Today we're going to be talking about right cylinders and right cones. Okay, now right cylinders and right cones are very, very, very similar to what we've done before with right prisms and right pyramids. It's almost exactly the same thing, except for now instead of having a polygon as your bases, now we have circles as our bases. Okay, so you'll notice there's a lot of similarities between the formulas for right prisms and right pyramids as there are for right cylinders and right cones. So let's get into this. So for a right prism, to find the lateral area, which is the area of the sides, all it was just perimeter times the height. Okay, that's all it was. And then the total area was the perimeter times the height plus the bases, 2 times the bases. And then the volume was just the area of the base times the height. So that's how you found all the lateral area, total area, and volume of a prism back in the day. Now we're talking about cylinders. So cylinders are like going to be the exact same idea as prisms, but now instead of having the perimeter, we have the circumference of the circle or the perimeter around the circle, right? So I'm going to label a couple things here. This here is the height. It's perpendicular to the base. And this is the radius. Okay. So the lateral area, or the distance just on the side of this cylinder, is going to be the perimeter of the base times the height, just like for a prism. However, the perimeter of the base of a circle is just the circumference times the height. So we could even do C times H if you want to look at it like that, which is equal to the circumference of a circle is 2 pi r. So it's just going to be 2 pi r h, and that's going to get you your lateral area. Now your total area is just your lateral area plus your two bases. So our lateral area was 2 pi r h. So 2 pi r h plus the area of your base. Now, if these are circles for their bases, it's going to be 2 times pi r squared. So there you go. If you wanted to, you could factor out a 2 pi r from both of these, make it look a little bit different, but you don't have to. And then lastly, we have the volume. So the volume before was base times height. It's the same thing here. It's going to be the area of your base times the height. And the area of this base is going to be pi r squared and then times the height. So there you go. These formulas are very, very similar to what you have for prisms, and they come from the same place. But now, just instead of having a base that's a polygon, now we have a base that's a circle. That's the only difference. Now, the same idea comes into play when we talk about cones versus pyramids. So for pyramids, you had a polygon as your base, and now here as cones, we have a circle as our base. All right, so for a regular pyramid, our lateral area, which is just all the sides, added up here, is 1/2 the perimeter times the slant height. And that's going to be the exact same thing for a cone. It's just going to be 1/2 the perimeter times the slant height. But we know the perimeter already. The perimeter of the base here is the circumference of the circle, which is just going to be 2 pi r. So really it's going to be like 1/2 2 pi r times that slant height. Okay, so figure that out. It's just going to be pi r l. Okay, so that's your formula for the lateral area. Now for the total area, again, it's just the lateral area, which is 1/2 BL plus the area of your base. So for a cylinder, or sorry, for a cone, it's just going to be the same thing. It's going to be your lateral area, pi RL, plus the area of your base, which is going to be pi r squared. Cool. And then lastly, we have our volume. So before, our volume was 1/3 base times height. That's going to be the same thing here, 1/3 base times height. However, we already know the area of a base, if it's a circle, it's going to be the same each time. It's going to be 1/3 pi r squared times the height. So these are your three formulas that you're going to need moving forward here. Okay. So so those are the formulas. Let's put this into practice here. So we're going to have two examples. So we'll start off with this example here. So the total area of a cylinder is 40 pi. If h is equal to 8, find r. So it's given us the total area of the cylinder. It's equal to 40 pi. So total area equals 40 pi. We are given h is equal to 8, and we need to find r. So we need to look for the total area of a cylinder. So let's go back up. Total area of a cylinder was equal to pi rl plus pi r squared. So instead of writing total area, I'm going to write pi rl plus pi r squared is equal to 40 pi. So I replace total area with the formula for total area. Yep. So we run into a little bit of a snafu here. We have an equation here, but we have two variables. We have the radius and the slant height are our two variables. Oh, whoops, I messed up. It's cylinder, not cone. So that actually makes this a lot easier. I looked up the wrong formula. So actually, this isn't the total area for a cylinder. Let's go back up and look for the total area of a cylinder. So this is a cone, not a cylinder. So we need to use this one, cylinder. So the total area for a cylinder is this formula right here. Oh, that makes it so much easier. Okay, so we have 2 pi r h. I'm going to go down and write that real quick. 2 pi r h plus 2 pi r squared plus 2 pi r squared. Okay, but we know h is equal to 8, so I'm going to erase that h there, and I'm going to replace it with an 8. Okay. All right, so now all we have to do is we have to do just a little bit of algebra. So here, this is going to be 16 pi r, so 16 pi r plus 2 pi r squared is equal to 40 pi. And let's simplify this a little bit. All of these things can be divided by 2, so I can divide all this by 2, and then I can also divide it all by pi. So I'm going to divide the whole thing by 2 pi. All the pi's are going to cancel out, and then each of these are going to be divided by 2. So I'm going to also rearrange them. So I'm going to have r squared, because 2 divided by 2 is 1, plus 16 divided by 2 is going to be 8, so 8r is equal to 40 divided by 2 is going to be 20. Hey, look at here. This is looking something like a quadratic. So since it's looking like a quadratic, I'm going to solve it like one. So I'm going to get it equal to 0. And then I'm going to factor it. So I got to think about what two numbers can multiply to get to -20, but add to get to 8. So I'm thinking 2 and 10. So it's going to have to be +10 and -2. Okay, so I factored, so I can check it real quick. So 10 times -2 is 20, 10 plus -2 is 8. All right, works out. So in the end, my r is equal to -10 or r is equal to 2. But however, one of these answers doesn't work. Which one doesn't work? Yeah, this one doesn't work. We can't have a radius that's a negative length, so that one's out. So it looks like our answer is r is equal to 2. Okay, not that bad. This one just required algebra and barely required any geometry other than knowing these formulas. All right, so let's move on to a slightly more challenging problem. So for 38 here, we are given that a 120-degree sector is cut out of a circular piece of tin. So I'm gonna just do this. So it's gonna be a pretty big sector here. We're just gonna say this is 120 degrees. Okay, with the radius 6. So here we go, 6 radius. And bent to form the lateral surface of a cone. What is the volume of the cone? So basically what they're saying is we're going to take this portion, we're going to cut it out, and we are going to turn it into a cone. So we're going to take this, turn it into a cone. All right. If we do that, what does this 6 become? Well, this 6 becomes our slant height. Okay. And from this information, we need to figure out some more interesting, like, well, we need to figure out some stuff. But one thing that we are, so if we were to cut this out, what it turns into is the lateral surface of a cone. So if we cut this piece out, the lateral surface is going to be equal to the area of this cone. So we need to look back and find what the area of the sector is going to be. So the area of a sector is going to be x over 360 pi r squared. And in this case, we know x is 120. So we're going to have 120 over 360 times pi, and then r is going to be 6. So 6 squared is 36. Do this out. This is going to be 1/3 times 36. So let me bust out the calculator. 36 divided by 3 is going to be 12. So the area of that sector is going to be 12 pi, which is the, so the area of this sector is 12 pi, which means that the lateral surface area of this cone is going to also be equal to 12 pi. So if we look back up at the lateral area of a cone, it's going to be equal to this. Or sorry, whoops, this. Pi RL. So we take the area of this sector and we set this equal to pi RL. We know the slant height is 6, so we take that 6, plug it in for L. We're going to have 12 pi is equal to 6 pi r, which means our radius is equal to 2. So now we have the radius, we have the slant height. We need to find the volume. So let's look up at the volume of a cone. We have 1/3 pi r squared. We need the height is what we need. So I'm going to write right down here, volume equals 1/3 pi r squared height. We need to find that height. So how do you guys suggest we find this height of this cone? Yeah, we use the Pythagorean theorem. So let's do it out. So h squared plus 2 squared is going to be equal to 6 squared. So do this out. H squared is equal to, so this is going to be 36 minus 4. It's going to be 32. So h is equal to square root of 32, which can be written down. So square root of 32, which is equal to, let's see if we can simplify this. So it's equal to 4 root 2. Yes. Yes, cool. All right, so now we plug that into the formula. So our volume is going to be 1/3 pi r, we said is 2. So 2 squared times the height, which is 4 root 2. Let's figure it out. So this is going to be 4. So it's going to be 1/3 pi times 16 root 2. I don't think, let's see, 16. Yeah, so unfortunately this is going to be a little bit messy. So it's just going to be 16 root 2 over 3 pi, which is equal to about, so 16 divided by 3, so 5.333. So I'm just going to do 2. So I got 23.7, but I did that on my computer calculator, so I'm not sure if that's 100% right because it's kind of got a weird interface, but I think that's about right. So there you go. So that's problem C. So my challenge for you guys this week, I want you guys to figure out this problem on the notes. All right. If you guys figure out the answer to this, comment in the comments below. Tell me what the volume of the water is, the volume of one ice cube. Actually, you know what? No, just tell me the total height displacement, and that'll be the answer. Okay, give me the total height displacement in the comments below. And the first one to do that in the comments below will get a specific shout out from me in the next notes. Other than that, that's all the notes we have for you. So thank you guys very much for listening, and I will see you all in class.